In this video, we're going to look at the engineering steps that you have to follow to be able to use Sequence Manager. In this example, we have a sample premixing tank where we can charge different materials into that tank, water, caustic and acid, but we can only charge each of those at one at a time. We can heat our premixer tank with a jacket heating, we can agitate our tank with an agitator, and we can transfer out the material in our tank to the next following reactor. Following the S88 structure, for each of the devices or analog inputs or PNID loops on our tank, we need something called a control module to monitor and control those devices. For our valves, analog inputs, agitators and pumps in this example, we've chosen to use the library of process objects, which is also used if you wish to execute a plant PX system. So here we have our valve with its example symbol and faceplate. We have an analog input for our weigh scale, again with its symbol and faceplate, and we have a pump with its symbol and faceplate. This library is free of charge. It provides you these symbol and faceplates, and it also provides you a corresponding piece of code in the controller. So let's go and have a look at the code for one of those valves. Here it is implemented, in our case, in function block diagram in the controller, but you could also use ladder logic or structured text. Having used that free library for our control modules, the next layer in S88 is something called an equipment module. This is basically a way of simplifying a complex set of operations. For example, maybe you wish to route from one tank to another, you have a set of routing valves, you have many different routes, and you want to simplify the control. You might decide that one way of doing that is to use an equipment module where you can put it into not being used, or route 1 or route 2 or route 3 for example, and it controls the sequence of steps to move from one route to another. In this example, in our simple example, we don't have any complicated situations like that, so there's no need for any equipment modules. Next layer up in S88 is something called equipment phase. So this is a simple operation that performs a simple function. So looking at our premixer example here, I've decided that we need an equipment phase to control the charge of material into our tank. Okay, so that gets given the material to charge and the amount to charge, and off it goes. It controls the sequence to charge that amount and then completes. Similarly, I've decided that I need an equipment phase to do agitation, so that will control the agitator for our tank. Again, I need a phase to be able to transfer out the material to the next reactor, a transfer out phase. I need an equipment phase to control the temperature in the reactor, so a heating phase. I wish to have an equipment phase that prompts the operator with simple messages and asks them to confirm and give a response to whether they've done it. And I need a phase to do timing, so I can time for periods of time. To use Sequence Manager, you have to implement these equipment phases using another built-in technology that's available in both control and compact logics, called Phase Manager. So here in our controller code, you can see that we have these phases: the agitate, charge, heat, prompt, timer, transfer out, which correspond to these phases shown on the graphic: the charge, agitate, transfer out, heat and prompt. These are implemented using Phase Manager, which is built into Logix and is a special type of program. What Phase Manager gives you is built-in S88 equipment phase state model into the firmware of the controller. So here we can see that state model. We've built that into the firmware, so it understands these states. It understands that if I'm in running, I can only hold and go into holding, or I can complete, or if I receive a stop and abort command, I can go into stop and abort. Okay, and if I'm in the abort state, for example, I can only process a reset command to go into idle. So the firmware takes care of that. You don't have to code that into your logic. What you have to worry about in the phase manager is which steps you want to support. So do I have a running step? Do I have a holding step? And then what do I need to do when I'm in them? So in our example here, we have our charge equipment phase, and this has the aborting, holding, resetting, running and stopping states. Okay, but if we go and look at our prompt state, it only has holding, resetting and running. Okay, didn't need the aborting step. Each of those steps you can then write in the language of your choice. So if we go and have a look at our charge phase and we go and have a look at our running step, we can see that that's been written in sequential function chart. Okay, so here is an example of that code. And if we go into our prompt equipment phase and look at that running step, we can see, as it's much more simplistic, that it's been written in ladder logic. The choice is yours. Equipment phases, just like any other program, have parameters and local tags. But they also have a special type of tag where you basically identify to the phase manager which of these tags are inputs into my phase, things that need to be specified when I start, and which things are outputs, things I'm going to report as I'm running and when I complete. So here I look at my charge equipment phase and I can see that I have some output values, the amount I actually charged, the lot I actually charged, okay, and I have some input values, the material I'd like to charge before I start, the specification of that, and the amount to charge. Okay, a bit further down, the set point. By specifying that, then when I use Sequence Manager to control these equipment phases, it will pick up those values and know that those are things that have to be specified in the recipe before that phase starts, and it will look at the outputs and it will record those outputs if you want to have Sequence Manager execution logging. So here when I select the charge powder, you can see that it knows that the material charge and set point charge are the inputs that are to be specified, and it knows those outputs that are specified are the things to record when it completes. Okay. So to execute Sequence Manager, you need to use equipment phases. You can then write as many Sequence Manager sequences as you can fit into the controller memory in your controller, and they can select any of the equipment phases that you have in your controller. You can run a simple type of recipe like you see here, where we run a single equipment phase, we run equipment phases in parallel, then we go back to single, or we can go to more complicated recipes where you can run those phases in parallel, and you can have loops as well if you wish, or diversions where you go from one route or another. And that concludes our video about what you need to follow to be able to engineer and implement a Sequence Manager system.